Hello there, and welcome back to another day where I have some free time. And in this day's video of unstd-c, we'll be continuing on with the functions that will help us merge, trim, and sort out the free functions. Well, not the free functions, the free chunks in the memory chunks that we have at malloc and free. So we can get started by going back to the malloc internal C and the header, as well as going to malloc and free. So first of all, let's go back to the header. Wait, this ain't the header. Where we will add a few more functions where it returns a heap chunk type. And I guess it can be something like find free chunk, where it will take the heap data and the size that we want from it. So size. And then this can either return a chunk that is greater than the size or equal to it, or null. So let us get to implementing that. So over here, we will use the fact that we already have the next chunk function implemented, and we can have the struct heap chunk t. Maybe we can call that r, make that equal to null. And while the return value from next chunk using d and r as its arguments, we will only break out of this function if the chunk it returns is freed and if the size it has is greater than or equal to the size. If not, it will just continue on until it gets to null. Wait, I've done this wrong. This should not be equal to null. So we return r and then we're all good. If we're only trying to find the first fit on the requested size. And I guess that is fine. We're not really going for optimizations here. I'm here to learn. So we now have defined free chunk function over there. And considering that we now have chunks, we may as well create the function to trim the chunk. So we'll take the heap data as well, since we will be trying to get next um the next chunk after this supposed chunk that we're supposed to trim. So heap chunk t, and this the target size that we have. So first of all, if the size of this, subtracting heap chunk size, is equal to 0, so it cannot create a chunk header after this thing when we trim it, then there's not really a point. So we just return. Though I'm thinking that this can also underflow. Though maybe the compiler will not do that if it tries to optimize things. But I guess we're also at the mercy of the compiler since overflowing and underflowing is undefined behavior in C. So if it does indeed underflow, we can also check that the current size will be lower if we try to subtract the heap chunk size here. And when that happens, it definitely underflowed and we return immediately. And then we try to get the next one from here. So the next, just run next chunk on here, D and C. And if next is not equal to null, then we can change its previous size to be equal to the current size of C subtracted by its target size. And we also subtract the header size of this as well. So heap chunk size. And we can also create the next one. Well, the new one after C was trimmed. So new. And we will calculate this manually since the size has not been done yet. Well, used yet. So destruct heap chunk D as a character pointer. Then instead of adding C size, we add just the size plus the headers. Now we also check if new, if this pointer is still in the heap. And if it is, then we set its size to be equal to this one's previous size. Also, the previous size of this will now be equal to the new size of C. And we set the freed status of this to true since this is a new chunk. Now, why am I checking if this pointer is in the heap? Well, mmap allocations can sometimes overlap if I've done the new heap function wrong. And it can overwrite the headers in another chunk, well, in another heap data. And that is a problem that I've had to be debug when I was testing things out. And this is the result of my experiments. So, anyways, let us continue. Now we can create the size. We can now make it equal to the size over here. And the previous size does not really need to be checked nor changed. So I believe this is it. Maybe. Though I feel like I am missing something. Okay, maybe not. Maybe we're all good. So let us go back to malloc C. And we try to find the free chunk. Find free chunk. And we give it the target size. And then we run trim chunk on that. On C. Also the target size as well. And then instead of subtracting the size from the size of the heap data, we subtract the size of the chunk itself. Then we return C plus 1. That does not change. There's no more need for gotos since there's nothing there. So we can remove that. And we also have got to make this freed status be equal to false. Else, we may run into issues later on. Also, let's go to free, where we do not need to add the free chunk into a linked list anymore since I've removed that. Also here as well. And no need for a go to here. So I guess it can remain like this. And I can change this condition to our macro that we have made. So is pointer in heap. Pointer and D. And I believe that is all. I also got to add that if the pointer is equal to null, then we do nothing as per the C standard. So let's go to malloc then. Now that we have the trimming and finding the free chunks available, when there's a heap data that has enough size for the the allocation that the user wants, well, you've also got to check if there's actually a chunk in that heap data that has the enough size. So find free chunk take cares of that. But if somehow it doesn't find one, so C is equal to null, then we allocate a new block. So over here, where it will just return null. And if not, then it will try to find a free chunk in this new allocation. And this is sure to find one since this is a new allocation, unless it's null, which we've already covered. And we can trim that to our heart's content. And then the only thing that I'm worried about is this last variable being null, which is a bit wrong. So I guess let's just create a function, maybe something like find last heap, and it doesn't take an argument. So let us go back to malloc internal h and actually declare this thing. And this will return heap data or null. Oops. So let us get started on that. And where is the buffer for that? So there's new heap. Then here is the last heap. So we have the struct heap data d set that to equal to null. And if libc memory is equal to null, then we return absolutely nothing since we can traverse a linked list of null. But while the next one on D, this should start at libc memory. I'm sorry. If the next one is not equal to null, then let us go back to traversing the linked list and we return D. So there are low stuff. And let's see, what did I possibly miss. We may as well edit the build file to add not optimizations but warnings, just in case I'm missing something. And considering that we do not have any formatting here, I can do what I want. So let's add all warnings and extras, extra warnings, maybe pedantic warnings as well, just in case. Now let's build this thing. And let's see. I actually did not add the trim chunk function here. So trim chunk, and that will take the structure for the heap data, the chunk to be trimmed, and the target size. So build that. And let's see, where is this? Oh, this is the next allocation in malloc. If in case it does not find it. So we might as well make this available at the top over here. And I guess I can change this to that. And let's see, over here in the 88. So malloc internal C. Oh, that should not be freed, but it should be true. Oops. Now, what else? Wait, did I set that to heap data if it's supposed to be a chunk? Yes, I did, apparently. Maybe I did the same one over here. Yes, I did. And the macros for mmap is not here, so I gotta include sys slash mman dot h. So let's try building that. And at free, was it 26? Oh, C does not exist anymore. So we can just make that a heap chunk size. And this can be the heap data size. So let's build that. Well, let's try a clean build. And not much warnings. Well, unless there's this in break, but I do not know how to use that yet. So let's run strace, and we have a seg fault. That is a bit surprising. We don't really have much time to debug in this video. So we will do that in the next one. So thank you for sticking with me this far, and may I see you on the next one.